Okay, great. Okay, looks like people can hear me, and I'm also live in YouTube and Facebook. So just a second. I'll try to remove this one. Okay, so I would request everyone to switch off the video. Please do switch off your video. Okay, I hope. Okay, so welcome everyone to the class. We will be discussing today something very interesting. I mean, this is related to, remove this, and okay. So we will be discussing something called platonic solids. So you can see me drawing on the board. Maybe you can see me writing on the board as well. Right. So in fact, I'll just open my video. Let's put my video here. Yeah, that's great. Yeah, yes, this is fine. Right. So we will be discussing something called platonic solids, and let's start with something absolutely simple. We will start with this. Suppose we have a unit cube like this. So can all of you draw a unit cube on your notebook? So if you have a pen and paper, draw a unit cube on your notebook. So start by drawing a single square like this. You can start by drawing a single square like this. Let me draw that in red. So the single square is like this. And you can draw another square which sort of overlaps the first square. So that one is like this. So draw two squares, each of them overlapping the other one. And then connect the corners like this. Okay. So let's give names to this corners. Can anyone tell me how many corners are there in this particular cube? How many corners are there? Can all of you hear me? Hello. You should be able to Okay, Tanuja Ranawat is giving answers. Excellent. So we are already getting some answers in the chat. Very nice. So indeed, there are 8 corners in this particular cube. 8 corners. So A, B, C, D, E, F, G, H. So what I'll do is we will give 8 corners, 8 names. So we have 8 corners and there are 8 names. Please switch off the video. If you are not speaking, please switch off the video, everyone. Okay, I'm repeating this over and over again. Please switch off the video. Okay, so now suppose we have the midpoint. Now let's count the number of edges. So what are edges? I'll mark the first edge using something like this. So AB is one edge. AB is one edge. Here you go. AB is one edge. Similarly, AD is another edge. AE is another edge. Okay, so AB is one edge, AD is one edge, AE is another edge. Can you give me the names of the other edges? Give me the names of the other edges. Okay, so I'm seeing BC, right? I am seeing DC. That's correct. Okay. I am seeing EH. Okay, EH is there. That's great. So we have EH and we have HG. HG is there. Right. And what else do we have? We have EF. We have EF and FG, BH, CG, DG, DH, and DC. So I have written down all the edges. I have written down all the edges that can be drawn connecting 2 points. So what is an edge? It's something that connects 2 points on this picture. Okay, so two corners. So there are 12 edges. Excellent. Your next question. How many faces are there? How many faces are there in this cube? Okay. So what are faces? So maybe I can draw the faces in red. Let me put one of the faces like this. So this one is one of the faces. So this face is A, B, C, D. So this is A, B, C, and D. So A, B, C, D. This is one face, right? Okay. So let's look at another face, which is this one, AEHD, AEHD. And then we have C. So there are four walls. You can see this. There are four walls in this picture. And there is a ceiling and there is a floor. There is a ceiling and there is a floor. Right. So in total, there are six faces. Six faces. So six faces. So this is the example of the first Platonic solid. The first Platonic solid, a cube. Okay, now let's draw something called the tetrahedron. Tetrahedron. Tetra means four. Tetra means four. So how do you draw the tetrahedron? What you do is you start by drawing a triangle. And then you mark another point. And then you can join that point with the three vertices. So let's name them. How many corners are there in this tetrahedron? How many corners are there in total? Of course, there are four corners. Excellent. So A, B, C, D. There are four corners in the tetrahedron. So number of vertices. We often call the corners the vertices. Okay. So there are four vertices. How many edges are there? How many edges are there? So you can again check that AB is one edge. AB is one edge. AC is another edge. CD is another edge. And AD is another edge. So 1, 2, 3, 4, 5, 6. Do all of you see the number of edges? Should be able to see it. AB, AC, AD. Then you have BC, BD, and then finally you have CD. These are the 6 edges. Can you see all the 6 edges? All right, that's good. That's great. Okay. Now, let's move on to the next Platonic solid. So, the next one is even better. So, this one is known as the octahedron. This one is known as the octahedron. This is so beautiful. This particular solid is so beautiful. Octahedron, I mean, if you have seen barfi, barfi is a kind of a sweet that people eat in different parts of India. So to draw the octahedron, you have to start by drawing a barfi on the board. So here you go. You start by drawing a barfi. So all of you draw this in your notebook. This is very beautiful. Okay, so I think all of you have seen burfi before in your life. You have eaten it somewhere and so on. So you know this. So draw a burfi on the board. Okay, draw a burfi on the board. And then draw a flat burfi. So how a flat burfi looks like? It's somewhat like this. So I have drawn a flat burfi, which is sitting like this on the in the octahedron, inside the big one. Okay. Okay. Now what I'll do is I join the corners. And I'll do this by dotted lines. In fact, I can change these two and make these two by dotted lines as well. Dotted lines means it's behind the picture. It's on the other side. That's the meaning of the dotted line. Okay, so now do all of you see the octahedron? Can you draw this in your notebook? Are you able to draw this on your notebook? You should be drawing this as we speak. Now, how many corners are there in the octahedron? How many vertices are there? Can all of you count? Okay. I'm getting answers now. That's great. Okay, Sana is saying, okay, so I'm getting many answers about the number of vertices. Okay, there are indeed 6 vertices. I can give them names: A, B, C, D, E, and F. So we have 6 vertices. How many edges are there? How many edges are there? So edges, let me mark them in red. So AB is one edge. AB is one edge. AD is one edge. AC is one edge. AE is another edge. BC is another edge. CD is another edge. Okay, so people are counting the number of edges already. So we got 6 of them. And now we can mark the remaining ones: BF, EF, DF, CF, ED, and BE. Right? Correct. So there are total 12 edges. Okay, how many faces are there? How many faces do we have? How many faces are there? Think about it. So this is an octahedron. So octa means 8. Octa means 8. So there has to be 8 edges. So here you go. 8 edges. Okay. Somewhat like this. So I can only shade 4 of them, but you can see the remaining edges, remaining faces at the back end. So there are 8 faces. Excellent. So what do we have so far? We have talked about the cube. We have discussed the tetrahedron. So this is how the cube looks like. And then we have the tetrahedron, which is this one is how the tetrahedron looks like. And now we have the octahedron. This is how the octahedron looks like. Okay, great. Finally, we will have, please switch off the video if you are not speaking, so very important. Okay. Now we will go into the fourth platonic solid, the fourth one, which is icosahedron. So we have the famous, this is a famous fourth one, the icosahedron. So remember, so far what do we have? We have the cube with 6 faces. The cube had 6 faces. The tetrahedron had 4 faces. Number of faces is 4 for the tetrahedron. Tetra means 4. Octahedron had 8 faces. So can all of you hear me, by the way? I see that some people are saying they cannot hear me. Can others hear me? If you can, please say yes, we can hear me. We can hear you. Okay, that's great. So those who cannot hear me, they have to check their system. Okay, that sounds great. Okay. So coming back to what we are saying, that we are ready to talk about the icosahedron. We are ready to talk about the icosahedron. So the icosahedron is a very, very interesting solid. It has 20 faces. It has 20 faces. Can you imagine this? We will be drawing this in a moment. It has 20 faces. All of these 20 faces are equilateral triangles. It was invented by the ancient Greek people. Okay. So when you're doing mathematics, you should pause once in a while to wonder what's going on, because it's so beautiful. It's like music. It's so beautiful. And it's not all formulas. There are patterns that we see and then we sort of try to understand them. So let's see how this icosahedron can be drawn. So start with a hexagon. Start with a hexagon. So how does the hexagon look like? Well, it looks like this. So you have a hexagon. Maybe I can do a little bit better. This is the hexagon. And what we will do is we will draw a triangle in the middle of the hexagon. We will draw a triangle in the middle of the hexagon. So I want all of you to actually draw this picture in your notebook. If you don't draw it, then you won't be able to appreciate what's going on. Okay, so you have this hexagon and you draw a triangle in the middle of the picture, in the middle of the hexagon. Okay, I see Dibyo Broto is showing me the picture, which is nice. Very good. Okay, so I have drawn a triangle. I have drawn a triangle inside the hexagon. But I have not drawn it randomly. What I did is I put a vertex of the triangle right in front of another vertex of the hexagon. And then how did I put the second vertex? How did I put the second vertex? Well, second vertex was moved, was put in a way that it is in front of another vertex of the hexagon. The third vertex was put in front of another vertex of the hexagon. And it was done alternatively. So if all the 6 vertices of the hexagon are like this, so A, B, C, D, E, F, then I put the first one with A, the second one with C, so I skipped one, and then I put the third one with E, and I skipped another one. So okay, so we are almost done, but we have to work a little bit harder. You have to work a little bit harder. So now I will draw a second triangle. So I need some monitors in the class. Some of the students, please, who are able to hear me and see me, whenever others is saying that they cannot see or hear me or cannot see the board, please tell them that you can, so that this chat disturbance is avoided. So they have to just do something. I don't know what they have to do. They have to download the Zoom app or something. Or actually, they can also go to YouTube to attend it. This is being live broadcasted in YouTube. So you can go to YouTube to attend this particular thing. So maybe I can just show this, give the link to YouTube of this particular broadcast. If you want, you can go to YouTube. Thank you. I see someone is saying, helping us out. So this is the YouTube link. You can always go there. Okay, so now coming back to what I'm saying, that there is another one, which is, I'll draw it in green, a second triangle like this. We have to do this very carefully. I'll say the channel name at the end of the session. You can go and subscribe there for Math Olympiad related videos and discussions and so on. Anyway, so let's focus on the class right now. We have this very nice triangle looking thing, but this is now inverted in some way. It's inverted in some way. And what I'll do is I'll put the vertices of this one directly in front of the other 3 vertices of the hexagon. Okay, so now I'll join this. With each of the green vertices, I'll join 3 vertices of the hexagon. Okay, and with each of the yellow vertices, I'll join 3 of the vertices of the hexagon. Okay, now the picture is ready. Can all of you see this in the 3-dimensional sense? Can all of you see this in the 3-dimensional world? It's a 20-faced solid, and you can sort of count it if you really are careful. It looks like a diamond. It looks like a diamond. The green thing is at the back. The green thing is at the back, and the yellow stuff is in the front. The green thing is at the back, and the yellow stuff is at the front. Okay, so can all of you see what we have done? This is a very fast way to draw the icosahedron. So I'll repeat what I just did. My picture was, I started off with a hexagon. So if you want to do this quickly, this type of drawing is sometimes known as wireframing. So I just drew it quickly. So I started off with a hexagon. I created one triangle. And then I changed the color just to make this look a little bit better. And I sort of created another triangle in the background. And okay, so here we go. I created another triangle in the background. So now each of the pieces in the yellow triangle were connected with 3 of these points in the hexagon. And each of the pieces of the white triangle are connected with 3 more pieces, 3 more vertices in the hexagon. And we have the so-called icosahedron. That's the 20-faced solid. The 20-faced solid. Now, you see, one thing you have to be very careful about in this, when you are drawing pictures like this, that there is a deep geometry related to everything that you are doing. There is a very deep geometry related to everything that you are doing. The way I am drawing the picture, I'm not drawing it randomly. I'm following a specific strategy to draw. Otherwise, if I had to draw a 20-faced solid, I would be in big trouble. It is not easy to draw. And even the drawing strategy has some geometry involved in it. So in the Math Olympiad program that we have, we of course go into these things in greater detail. Now let me make an announcement here to all of you that there is this, so maybe I can show this to you. Just a second. Okay. So we can go into this chinta.com/Bose. So this is the name of the Maths Olympiad that is coming up. I'll give you the link to this, and you can go there and sign up if you have not signed up. I'll give the link in the description. Okay. So this is, I put it in the chat. So it's chinta.com/Bose. Now, if you are coming through an organization, or if you are referred by someone, a school or some person or some coaching center, they will probably have a code, an access code that you can use to register for this. So you'll see that there is an access code necessary. So you should be able to register for it. And this Maths Olympiad is coming up in the month of July. So we will have some more training sessions like this. And then we will start the actual online Maths Olympiad. The students from various parts of the world are actually participating in it. If you want, you can also log into our YouTube channel and get subscribed there, because that is one of the best resources that you will find on the upcoming contest of Maths Olympiad that we will be conducting. So I will send you the link to that as well. Give me a moment. So here we go. Okay, so here is the link to the YouTube channel. So both of these things, you should go to the link chinta.com/Bose to register, and you can also go to the YouTube channel and subscribe. The next session is next week at the same time. And if you want, you can contact your connected collaborator or your school or something, to whoever told you about this session, to register for the actual Math Olympiad program. So that's a year-long program that happens online. It's for some of the best kids around the country. So you can also do that. Okay. Uh, uh, for the moment, keep on doing great mathematics and make sure to be absolutely creative when you are doing mathematics, because that's what will count, not formulas and all those kinds of things that you have to just keep in mind and memorize. For today, we will stop out here, and I'll see you next week at the same time. Thank you and good night, all of you.